Hey everyone, today we're doing lesson 18, subtracting inequivalent expressions. So we have moved on from the inequalities that we've been previously talking about. We've got a few more lessons to kind of wrap up Unit 6, and today we're jumping back to expressions here, solving expression problems, and we're going to talk about the distributive property a little bit more. For the first activity, it asks you to find each sum or difference mentally. Don't use a calculator. So take a moment, please look at these four expressions and go ahead and solve them. All right, for each of these, um, we have to go back to our integer rational number rules. Remember, when we're adding two negative numbers, it just stays negative and gets more negative. So this first one would be negative 40. Now, the change that's happened in the next expression is that the two terms that are being added have just switched directions. In addition, if we switch the two add-ins, that makes no difference in our sum, so that's going to have the exact same answer. Now we look at subtraction, and for this first one, negative 30 minus 10, we're taking 10 more away from the total. So that would be also negative 40. And one thing I want to point out here is that by subtracting 10, we are also doing the same thing as adding the opposite of 10. And remember, when we did these integer subtraction problems, a lot of times we would take that expression and we would rewrite it using addition. But instead of adding 10, we add the opposite of 10, so we're adding negative 10. And now you can see we have the exact same expression as we did in these first two cases. It's just switched directions. For the last one, we are subtracting negative 30. So you can see the change here going from this expression to this is that the two terms have changed their order, changed their direction. And we're doing a subtraction problem. So in subtraction, we can't reverse the two numbers, or we get a different result. We get a different difference as our answer. And what happens is if we take 10 minus negative 30, we actually get an answer that is 40. Now, going back to what we were talking about in the last one, if we rewrite this using addition, we would write 10. We're going to add the opposite of negative 30, which is 30. And you can see how this is a very different problem than what we got here. 10 plus 30 or negative 30 plus negative 10. So switching the order in that subtraction problem does not work. But it's important to see for today's lesson that these three problems are all equivalent. We can switch the direction or the order in an addition problem, and that's fine. And if we turn a subtraction problem into an addition problem, we have to add this opposite value. The only thing that won't work is to switch the direction in subtraction. There we have a problem. All right, moving on to the next part, which is going to kind of reinforce that idea we just talked about. So Lynn and Kieran are trying to calculate the expression here. Here's their conversation. Lynn says, I plan to first add 7 3/4 and 3 5/6. All right, let's look back. So adding those two things. So I will have to start by finding equivalent fractions with a common denominator. All right, if we look at that, that's true. You can't add fractions unless they have a common denominator. So we would want the least common denominator, which would be 12 in that case. Kieran says it'd be a lot easier if we could start by working with 1 3/4 and 7 3/4. Can we rewrite it like this? Okay, I agree, Kieran, that would be much easier to do because they already have common denominators. Let's look at how he rearranged it. So he took the final term here, 1 3/4, and moved it up into the middle of the expression. Lynn says you can't switch the order of numbers in a subtraction problem like you can with addition. 2 minus 3 is not equal to 3 minus 2. And we just, again, kind of confirmed that with our last activity. Looks like Kieran did do that. He switched these two places, which is reversing that subtraction problem. Kieran said that's true, but do you remember what we learned about rewriting subtraction expressions using addition? 2 minus 3 is equal to 2 plus negative 3. Okay, here he's correct. That would be a correct statement. So we need to write an expression that's equivalent to their original and uses addition instead of subtraction. So we're going to use addition instead of subtraction. That's not going to change my first term. So 7 3/4 is fine. Then it was plus 3 5/6, still good. So we're just copying so far what's happened. Now we're going to change this subtraction to addition. And based on what Kieran just said here, we need to, if we're going to use addition, we need to add the opposite of that second term. So the opposite of 1 3/4 is negative 1 3/4. And it'd be best to put that in parentheses just to kind of set that negative number apart from the addition here. All right, so that would be a way to rewrite this only using addition. We've just made this last term a negative term, and we've done that before in solving equations just the last couple of days. In the next part, it says, if you wrote the terms of your new expression in a different order, would it still be equivalent? So now I would say let's go back to, let's see, what Kieran said up here, where Kieran said it'd be a lot easier if we could put together the two terms that have a common denominator. So let's try that. If we take 7 3/4 plus our other 3/4 term, which is negative 1 3/4, and then we add on the 3 5/6, would that still be equivalent? Well, all we did was took an addition expression and wrote it in a different order. And with addition, it doesn't matter. All we're doing here is combining three quantities. One of them is negative, but we're still just going to combine them. The same would happen here when we rewrite it. We're just going to combine it a little bit differently. In this case, it would be easier because they already have the common denominator for the first two terms. So we could combine these without having to recalculate these fractions. Now, we're going to talk a little more about these tape diagrams. Actually, I'm sorry, this is not a tape diagram. This would be more like an array. And if you remember, we use arrays with multiplication. If we have, I'll give you a quick example, array. If we had 3 and 2, we're showing multiplication of 3 and 2. We're showing that there's 2 rows here and 3 columns here, and it demonstrates what our total product would be, which would be 6. That's what's happening here. The difference is we're using some different terms. We've got a fractional number of rows here, but in essence, we're just taking 1/2 times each of these quantities that are written across the length of the array, across the length of the rectangle. So this is finding the area of this shape. And to find the area of a rectangle, remember we multiply the length by the width. Here we have the length and the width. We just have our length split into 3 parts, and some have variables, different variables with them. All right, so we're going to write an expression to represent that area. We don't want to forget, but it says write 2 expressions. So our first expression, we need to take 1/2 times all of those quantities. Now, to me, that sounds like an expression that would have parentheses with it, because we're going to take 1/2 times 8y times x and times 12. Now, all 3 of these terms make up the length of this array, so we need to combine them. We need to add them together. This would be our expression. It's not an equation because we don't know what it equals here. All right, so we'll leave it right at that. Now, the way to write a second equivalent expression for this would be to actually multiply 1/2 times each of these things. That's distributive property. So, using a different color here, if I have to multiply 1/2 times each part of the length, I'm going to do that to the best that I can. I obviously can't get rid of these variables since I don't have the value of those variables. I can't simplify it much, but I'm taking 1/2 of 8y. Half of the 8y's here is going to be 4y. Half of the 1x that we have here gives me half of an x. And half of 12 is 6. Now I would still add those all together just like they were in the original length of the array up here. All right, hopefully that makes sense to you. Let's look at the next one. And it says, this one specifically tells us to use the distributive property to write an expression equivalent to this. So we're given the expression that we would have written first, which is 1/2 times each part of the length. This is very similar to the one that we just looked at. The difference is these two values are negative now. So that's going to alter how we multiply these just a little bit. We're going to have to follow our multiplication rules for negative quantities. And would you please go ahead and use the distributive property to rewrite this in an equivalent expression? Okay, remember that we're taking 1/2 times each of these three parts of the length. So we're taking 1/2 of 8y's. That's the same as the last example, so that's going to give 4y's. Now we're taking half of a negative x, a negative 1x. Okay, multiplying one positive and one negative gives us a negative 1/2 x. And then the same with the negative 12. Half of negative 12 is negative 6. So, let's see. So we've got these negative amounts, but they were all being added together here in the original expression. We can still do that. We can still add these negative amounts. It'd probably be best to put them into parentheses like that, but this would be certainly a fine way to write that. Let's get to the next part, which again is a very similar expression. We're doing the same thing here with distributive property, but we're going to write 1/2 times 8y, still gives us 4y. 1/2 times x is 1/2 x, and 1/2 times 12 is 6. The difference is in this original expression, they're subtracting them. So we'll just stick subtraction in there between it. Now, we need to compare these, and I kind of wish I had them on the same page. But if we look at what we've done here, in this first expression, we just found half of these three quantities. No difference, we were adding them all together. So that one, I think, is pretty straightforward. This one changed a little bit when the terms became negative. So now all of a sudden we found ourselves still with negative terms, just like they were originally before we distributed, but it kind of stayed the same. And in this case, we were still adding negative quantities, In the next one, we're actually subtracting those quantities, and that would actually give us the same result as this one. These two expressions are equivalent. If I write the one from the last page, it was 4y minus 1/2 x minus 6. Hopefully you can see the comparison here. We've got our 4y. If we're adding a negative amount, that's just like subtracting it. And same for adding -6, it's like subtracting 6. So we have two equivalent expressions that would get us the same result. Honestly, this is a nicer way to write it just because it looks simpler. It has less symbols. We're not adding negatives, we're just subtracting them. We got rid of our parentheses and everything. This is a cleaner way to write that expression. But it's not always the most useful. Sometimes we might turn something like this into this because once we have addition, we can rearrange these terms how we need to, just like in that example with the fractions. So it's important to know how they're equivalent, going back and forth to both of them, so that you can kind of use it to your advantage either way. Okay, finally, we've got an expression 4 minus x. Just to practice this skill just one more time, I want you to find in these 5 expressions all the expressions that are equivalent to 4 minus x. All right, now thinking back to what we just talked about, we can't switch directions of those two terms. If we have x minus 4, that is not equivalent to 4 minus x. So that means that this would not be a good choice, and I don't see any others using subtraction, so we're good there. We did, however, say for an equivalent expression, you can always add the opposite of this last term. So 4 plus the opposite of x, which is negative x, would be an equivalent expression here. So we have 4 plus negative x there. And now we need to look for something else that would be equivalent. Well, now that we have addition happening, if we reverse the order of our two terms, if we write negative x plus 4, that should be equivalent as well, which would be right here. Let's look at these other two though. So if x is our negative quantity when we switch this to addition, can we just transfer that negative to the other term and call it equivalent? We certainly can't because those are very different values. So that would not work out here. And we can't just altogether get rid of the negative or maybe just change the subtraction to addition. That wouldn't be equivalent as well. So you can see the two that are. I hope this was more like a review lesson to you. I hope this stuff is becoming kind of familiar as we've gone from expressions to equations to inequalities through this lesson. I'm happy to answer any questions that you have, and please take a look at today's practice problems. Have a great day.